Have you ever experienced jet lag? How about shift work? Have you ever worked a few night shifts and then had to adapt back to working during the day again? What did that feel like? The fact of the matter is that even when you're getting a normal number of hours of sleep in every 24-hour period, having an inconsistent or disrupted sleep schedule can alter the way your mind works. This is because we all have a circadian rhythm, like a clock, built into our brains that tells us when we are supposed to go to sleep and when to wake up. We are at our best when we can maintain stable, consistent sleep schedules that allow our circadian rhythms to tick along in a stable and consistent manner. Our circadian rhythms are more like suggestions than orders, though. They can adjust and adapt based on external factors and conscious decisions. Whenever your circadian rhythm is disrupted, there are a variety of effects, some of them obvious, some of them subtle. And it is vitally important that we fully understand exactly what happens to us when we disrupt our circadian rhythms, because doing so is really common and has become increasingly common in our modern age of shift work, 24-hour businesses, jet lag, and the endless methods we've devised to expose ourselves to bright lights late at night. To this end, I have been researching one of the less well understood effects of circadian disruption. I want to know what effects these disruptions have on the behavior of a specific part of the brain called the hippocampus. So, why do we care? The hippocampus is the brain region that is heavily involved in memory formation and spatial navigation. Your ability to know where things are and what you did 5 minutes ago are critically important skills that you can thank your hippocampus for. To study the way that the hippocampus responds to circadian rhythm disruption, I am going to use an MRI machine to observe the patterns of brain activity that occur when people do things that rely heavily on the hippocampus, things like visualizing a location or learning new people's names. Now, using fMRI techniques, I'll be able to then see how patterns of hippocampus activity are influenced by a person's recent sleep schedule. My goal with this is to determine in the most direct way possible whether the stability of our circadian rhythms significantly influence our hippocampi. I'll also be running a second experiment asking the exact same question, but for mice instead of humans. In this second experiment, I'll observe their hippocampi down to a cellular level using two-photon microscopy techniques. By contrasting the neural activity of the mice with disrupted circadian rhythms with those of undisrupted mice, I'll be able to specifically identify what neurons are having their behavior altered in what ways. Now, by running these two complementary experiments, I'll be able to understand the way that this important region of the brain responds to circadian rhythm disruption. The understanding will create a clearer picture of the impacts of sleep-shifting behaviors. In fact, this research should lay the groundwork for the discovery of solutions to help improve the lives of shift workers.